I'm always looking for the chemical reaction. I am looking for the chemical reaction for this one. There it is. Okay, experiment 1, straightforward. That's your chemical reaction, okay? So for both of the experiments, you're going to be using, this is called sodium hydrogen carbonate or sodium bicarbonate. And just so, and I'll kind of note, I'll let you know, this powder stuff over here, I hope you're neater than I am. I tried to go ahead and put, this is sodium, this is NaHCO3 right here, sodium bicarbonate. I go, oh my gosh, you spilled. I did. But if you've ever brushed your teeth with baking soda, that's what that stuff is. Baking soda, you know, we use in cooking and to brush our teeth with and to put on bee stings. Have you ever done that? Okay, that works, I think. Okay, that or cornstarch. But that's what that is. So the first experiment you're going to be using, I think it's 3 molar HCl. It's in the first hood. Okay, and this is what you're going to be producing. Just to kind of give you a precursor with your first experiment, you are going to stir the heck out of your product to drive off all of the CO2. Okay, that's kind of in a nutshell what you're doing. What's that? Wow. Okay. Week? Okay. Then you only have to do the calculations and hand in the data sheets. Okay. Then no, what's that called? Summary required. And the summary is the experimental and the results and discussion. Any questions?
Is next Thursday or Tuesday?
No. I think so. I think next Thursday you're doing a titration.
So we don't need this book at all today then?
Right. Don't need that book at all today. But part 1 that you're going to do today is the same as part 1 in experiment 6. Okay? Very good. So if you the
chemical reactions in our lab report that's due today?
yes. Yes. Okay. And the second part of your experiment is that you include the chemical reactions. Okay. So figure out, this is so exciting, and I told you this is the first time I've done this one. You are going to figure out which of these reactions is going on in your second experiment. Okay. So put another way, is it this one? Is it this one? Is it this one? In all cases, you have the same reactant, the NaHCO3 again, and in all cases, you're going to apply heat. Okay? And honestly, I'll just kind of tell you, so we're all on the same page, you are going to weigh back your product, and you're going to see if the mass is this, or if the mass seems like it is this, or if the mass seems like it is this. I don't know if that makes sense, but I'll kind of talk you through it. Okay, so it's an exploratory sort of thing. Nuts and bolts of what you're doing for experiment 1. Notice what this says is I'm going to tell you about experiment 1 first, where you're going to mix the NaHCO3 with HCl. But this says you might want to go ahead and have somebody start experiment 2, because experiment 2 has some waiting time. Okay, so experiment number 1 looks like this. Your reaction vessel is your larger of the 2 Erlenmeyer flasks. Don't put it in the small one or you're going to have a mess. Okay? And this is the first semester I've done this. I feel so much like you guys could be less messy than I am with your 3 grams of NaHCO3. You guys are going to go ahead and weigh it out yourself. Okay, usually I kind of have little test tubes with it there. So you're going to use the balances and everything. Notice it says to get the weight of this, put it down in your lab notebook, okay? And then it says to go ahead and add about 3 grams of that powder. And it says go ahead and record the mass of the powder and the Erlenmeyer flask. And by difference, you have the mass of the powder, which is the NaHCO3. Then it says that you're going to use your 50 ml graduated cylinder. Underneath that first hood is that acid you're going to be using, that 2 molar HCl. There is a dedicated transfer beaker in front of that jug of 2 molar HCl back there. So you are going to, it says get 40 milliliters with 2 significant figures, but honestly, if you read what you're going to do, you're going to get a mass of your HCl solution. So get a mass. Step number 3 says, before you dump it, okay, you're not going to dump it, you're going to be a little more methodical than that. But before you combine your HCl to this, okay, it says get a mass of your HCl in your graduated cylinder. Record it. Okay? And then, like it says, after you've emptied it, you're going to weigh it back. And by difference, you get the mass of your solution, your HCl solution. All right? So step number 4 says kind of how methodical you are going to add the HCl to your cute little Erlenmeyer flask. It says add a small amount from your grad cylinder. Okay, let it fizz. It's going to fizz vigorously at first and then kind of die out a little bit. Ultimately, you're going to dump the entire contents of your graduated cylinder into your Erlenmeyer flask. Okay, so this step number 5 says weigh back your empty Erlenmeyer flask. Okay, and step number 6 is basically whoever doesn't have carpal tunnel does this for 5 minutes. Okay, and so what we're trying to do is drive off all of that carbon dioxide gas. Everything else is going to stick around. And so here in a minute, we're going to do a mass balance that you're going to see that the products you end up with are lighter than the reactants you started with. Of course, we know matter was not lost, but it was lost from your beaker. It was released to the room. You just added to global warming, okay? So that's kind of the nuts and bolts of what we're going to do. Next part. Okay. Oh, wait a minute. One more thing. Important. Number 7. Dun, 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 dun. What's number 7 say? After you've swirled it to get off all your CO2, don't dump it. Get one more mass on it. Okay, you're going to record that, and now you've got all of the masses you need to go ahead and get what CO2 is driven off. So do not dump that thing. Okay, check yourselves. Okay, so the second experiment is pretty straightforward. Okay, I have the Bunsen burner set up over there with the ring, okay, and the wire gauze on top of the ring. I'll put out the matches and such. And so you guys are going to use your, as your reaction vessel, you're going to heat that stuff, but as your reaction vessel, you're going to use this, okay? And let me see, it says that step number 1 is to, like what you did before, to make sure that you have this as dry and free from oils as possible. So it says, without anything in it, go ahead and heat it up for 5 minutes and let it cool down, okay? And then when it's conditions, that's called conditioning, use your tongs and go ahead and take it over here. Get a weight of the, it says after it's cooled, step number 1 says get a weight of your conditioned evaporating dish. Okay, then go ahead and be neater than I am and add 3 grams of the sodium bicarbonate, the NaHCO3, okay, to your conditioned evaporating dish. Get another weight, and by difference, you know your solid. So step number 3 is to go, so you always wanted to take baking soda and burn it, didn't you? I just know you did. Okay, because step number 3, that's what you're going to do. You're going to heat it up. Notice we're going to use a technique to see if we are kind of heating to constant mass, in a sense. So let's see. Step number 3 says 10 minutes there. Okay, where did it go? Step number 3, 10 minutes. Okay, so 10 minutes. So you have some babysitting time. So like I said, you can kind of be going back and forth between experiment 1 and experiment 2. Okay, as long as you guys know what you're doing. So you're going to heat your sodium bicarbonate for 10 minutes. Okay, you're going to allow it to cool. You're going to weigh it. Okay, and then step number 5 says you're going to repeat. Okay, basically step number 5 is for just 5 minutes now. Go ahead and heat it again. Let it cool down again and weigh it again. And hopefully you haven't lost any mass or gained any mass between those 2 heatings. Does that make sense? Okay, so that's what you're going to do. Record both of those masses. Okay. Once you have your solid product, which you don't know what it is till you do the stoichiometric calculations. Once you have your solid product, actually the stuff that's the residue that's left in your crucible, or sorry, your evaporating dish can just be discarded. That says down the drain or in the Ryan. If you have your calculations written up and go ahead and copy your data, if you have it written up and that sort by 1 o'clock when you come in, then you don't have to do the summary.
Every time?
No, just this time. No, you guys need to push yourself through that. But there's just so many equations, and I have to read them. And blah. Okay, so count on it. So, And then next time's your exam, so it's kind of the same deal for your exam.
So
Anyway.
basically for the next 2 weeks, we just have to have calculations and,
If you have them done by 1
It's just
p.m.
really nice.
okay.
Oh, thank you. No, I won't renege on that, but yeah. Yep,
Alright.
all right. Okay,
But
so,
it's easier.
so on the next page, actually, pushed out on Twitter. So we're all kind of hopefully getting used to, if you want to see things that I'm trying to share with you, this is out there on that first column when you go to the course homepage, an e-companion. Okay, so let me know if it's not there, because if it's not there, I'll figure out. So here's the deal. With the part 1 that had, remember what part 1 was, this one, okay? This is part 1, okay? So basically, you're supposed to come up with the mass of the reactants. The mass of the reactants was your sodium bicarbonate plus the mass of that HCl solution you had in your graduated cylinder. Add those together. That's the mass that you started with, okay? Step number 2 says, what is the mass of the CO2 that you drove off? Okay, here's the deal. You have the mass of the reactants, and remember I told you to get a mass before you dump it? Okay, you have the mass of the solution. I told you you're going to see some mass is gone. That's the mass of the CO2. So by difference, you can get to the mass of the gas. Oh, that rhymes. Okay. Calculation 3, it says calculate a theoretical mass. Anytime you see theoretical, start thinking, usually think stoichiometric calculation. The sodium bicarbonate, this messy white stuff over here, this baking soda, I get baking powder and baking soda mixed up. This baking soda is your limited reactant in both of these, okay? So to get to the mass of CO2, you're going to start with that mass, about 3 grams. Do a stoichiometric calculation. Of course, you'll need the molar mass of the NaHCO3 to get to moles. The stoichiometry, if you go back and look at your write-up, it's boring. It's 1 to 1 to 1 to 1 to 1. Okay, so it is balanced, what you see in your write-up. So you're going to use that ratio to get to the moles of the CO2. You're going to have to use the molar mass of CO2 to get to grams of CO2. That's your theoretical yield. We've done percent yields before, but number 4, calculation number 4 is kind of related to that. We're after percent error. And percent error is always, oh, dang it. Percent error is not that. Let's see, I'm going to erase it. And I'm going to have to, I could do this. Why isn't it erasing? Okay, fine. Percent error, what you do is you put the difference on the top. Oh, gosh. And then in the bottom, you put the theoretical. So I guess I kind of just need to switch these. So the top is the theoretical minus actual, okay, and you divide by theoretical. It's totally not that, is it? What was I thinking? Let me know if you have any questions. Theoretical, that was your stoichiometric calculation, minus actual. That was what? Calculation 2, very good, divided by theoretical. Final answer. This one right here.
How many times is 500?
Yeah, times 100 to get parts per 100. Thank you. And actually that is in an appendix in your, the yellow books that everybody just put away. Okay, if you have any questions about that. Okay, so that's percent error. And then step number 5 and 6 kind of go together. They turn your attention to that HCl solution that you added, and we're going to kind of make sure that it was in excess. So step number 5 says, what mass of HCl would you need to use if you used up your whole 3 grams of sodium bicarbonate? So you're going to use your mass of your sodium bicarbonate, go to moles, using the molar mass of NaHCO3, go to moles of HCl using the stoichiometric ratio, using the molar mass of HCl, find out the mass of HCl. Then step number 6 is, that's fine, that's the mass of pure HCl you'd need. Calculation number 6 says, well, what mass of HCl did you have in that Erlenmeyer flask, that 40 mils of, there are 40 mils in your grad cylinder. So basically, step number 6 says you're going to use the mass of the HCl that you had in your graduated cylinder, about 40 mils, but what was the mass? You should have that. And your instructions say that the 2 molar that you're using is 7%. So that means there's 7 grams of pure HCl in 100 grams of the solution. Okay, so, and calculation 6 says, for full credit, it says go ahead and kind of say, if that's what you have, compare it to what you needed in calculation 5. Okay, dun dun. On to the last part. Okay, experiment number 2. Remember I said that we don't know if it's reaction 1, reaction 2, or reaction 3? So basically, in order to find out which reaction is going on, you need to do a stoichiometric calculation in each of the cases, starting with the mass of the NaHCO3 that you burned, okay? And going then to find out how much of the product of that solid you would have. Okay, so that's what I've kind of outlined in 1, 2, and 3. Grams of sodium bicarbonate to grams of NaOH. Grams of sodium bicarbonate to grams of Na2O. Grams of sodium bicarbonate to grams of Na2CO3. So what it says there at the end then is basically which of these grams do you have? You've got a mass. Remember, you weighed the mass of your residue. I hope you weighed the mass of your residue. And which mass does it line up with? Whatever mass it lines up with, that's your reaction. Okay, step number 4 says which reaction do you have? And hopefully everybody has the same chemistry going on here today, okay? Any questions? Okay. All right.